بسم الله الرحمن الرحيم رب زدني علما.
So the next option with respect to marking, we have something called DSCP, Differentiated Service Code Point. Like if you remember your IP packet, it has eight bits, which is reserved for marking, for L3 marking. And in that, probably if you're using IP precedence, the previous one, it was using 3 bits, but whereas your DSCP value, it is going to use the 6 bits. So which means there are 6 bits which will be used. So based on these 6 bits, there will be different numbers it will generate. And accordingly, the priority will be different for different marking options. Now in this, out of these 6 bits, we can say like the first 3 bits are typically referred as a per hop behavior. So out of the 6 bits, we can say the first 3 bits, we call it as a per hop behavior. Per hop behavior is same like the priority, and higher the number, the higher the priority. So basically that's what this first 3 bits refers to. Again, we'll convert that into decimal and we'll see exactly how it looks in when we try to mark. Whereas the remaining 3 bits, now the next 3 bits here, we call this as a drop probability. Now basically drop probability means in case if there is any congestion. So let's say the router is forwarding some traffic over some interface and this particular link experiences a congestion. So let's say there is a congestion on this link, and if there is any congestion, probably it has to drop the traffic. So if you are configuring some kind of congestion avoidance mechanisms, which we'll cover probably later on when we talk about weighted random early detection options. So now it has to drop the traffic. So based on that, it's going to decide which packet is most likely to get dropped. So this particular bit, the last 3 bits, is going to decide the drop probability of that particular marking value in case if there is any congestion. So based on that, we have all these categories. So the first, we need to understand the 6 bits. In that, the first 3 bits, as I said, per hop behavior, which is going to decide the priority. And the next bits will decide the drop probability, which means in case if there is any congestion, what will be the possibility for that particular traffic or the traffic coming with those marking values of getting dropped. So let's try to see a little bit more detail here, options. So to start with, here, if we just see here, so DSCP identifies, we also have something called class selectors here. Now class selectors refers to the same like your IP precedence, a backward compatibility. So here you can see there is a 0, 1, 2, 3, 4. So these numbers will be decided based on this first value. So which defines the priority. So either you can write, if you want to have some kind of backward compatibility with precedence, then we can also define them in the form of class selectors. So this is equivalent to your IP precedence values. So you can either just simply give the marking value as 0, 1, 2, 3, 4, 5, where you need to specify as a class selector instead of IP precedence. Or if you want some, but again, the issue here is we don't have any kind of drop probability or additional options here. So if you want to have some additional options, then probably we generally write in the form of this AF and EF. So if you see here, all are written as AF. AF stands for assured forwarding. And we have multiple AFs with some numbers beside that. We'll again see those numbers next. And we also have something called EF. EF stands for expedited forwarding. And if you see the marking value of EF, there is only one EF value here, and that represents 5. Just like your IP precedence, 5 is like highest priority traffic. So if you are sending any specific VoIP traffic and you want that particular traffic should be given the topmost priority in that scenarios, and you want to do a marking based on DSCP, then we'll give with something called EF. So EF is exact equivalent to IP precedence of FI, the highest priority traffic. So we call this as expedited forwarding. In terms of binary, this is how it represents. But basically, we don't need to really worry about the binary values here. So let's try to see first EF, expedited forwarding, what exactly it says. So expedited forwarding is going to provide a guaranteed bandwidth with high priority. So any traffic is being received with EF marking value, it will be treated as highest priority. So in terms of all the values, if you see, the topmost priority will be given to any marking value which comes with EF. And again, in case if you are specifically saying, let's say there's a VoIP traffic which should be given a priority of 256 kbps, and probably we can do that. We can even say that in case if it exceeds, that traffic can be forwarded or dropped depending upon the conditions. And the main thing about the EF is there is no drop probability bit here. So which means this traffic is considered as highest priority and there is no dropping chances. Okay, so it's more like equivalent to the IP precedence value of phi, which considered as the highest priority traffic, and it will be always forwarded first, depending upon the options. Means if there is any congestion, this any traffic marked with EF will be always forwarded first. The next, again, we have something called assured forwarding. Now, the assured forwarding is about the same like EF, but again, in assured forwarding, we don't have single number. If you see here, we have AF almost 12 values here. We have AF 1, 2, 1, 3, 1, 3, and then 2, 1 with 2, with 3, and with 4. So there are 12 possible values you have. And the AF stands for assured forwarding, is just like guaranteed bandwidth, which means any traffic which is coming with AF, it guarantees a specific bandwidth. And with AF, we have 4 possible values. So if you just see the binary values of this AF, so if you just quickly write down this AF values here, we have AF. Now, again, there are 3 bits. If you remember, I said the 3 bits will decide the per hop behavior, and the remaining 3 bits will decide the drop probability. So in these 3 bits, again, in terms of this per hop behavior, again, we have 1, 2, 3, 4. There are 4 possible numbers. So which means if I'm receiving anything with AF1 and if I'm receiving AF4, the higher the number, higher the priority. So the per hop behavior defines the priority for the traffic, which means the priority will be given to AF4 when you compare with AF1. Okay, so in terms of the first number will decide what will be the priority of that particular traffic here. Like in our case as well here, if we try to see here, we can see these are the AF values. You can see these are binary values. Of course, this is AF1, and then we have AF2, and then we have AF3, and then we have AF4. So there are 4 possible numbers, just like we have in IP precedence. If you compare the same thing with IP precedence, we have 0, 1, 2, 3, 4, 5. So in our case, the phi is EF, and whereas these 4 values are, again, we have something called AF1, AF2, AF3, and AF4. So the difference here is it's not just 4 values. Inside each value, like AF1, again, we have three combinations in that. So if you compare this with AF, the first number, that this is 1, 2, 3, 4, the first number will decide the per hop behavior, nothing but priority. And then the second number, we have another number here. So this number can be anything from 1 to 3 combinations. And this second number, if you take this one as 1, 2, 3 here, now this second number will decide the drop probability, which means if I write down the combinations here, it will come as A of 1. Let's say if I write A of 1, we have 4 values, A of 1 and then A of 2. So the 3 values here, and A of 3 and A of 4. So this is A of 3 and then there is A of 4 here. So again, the next numbers, it can be just 1. Sorry, there will be 4 as well. You write either 2 or you write either 3. So when you're writing these combinations, you can see the combinations here anyway. When you see the combinations here, now this number will decide the drop probability, which means, let's say if I'm receiving any packet with AF 41, now if you see this marking value, as per this marking value, we said this 4 represents the per hop behavior, the priority, which means this is considered as high priority traffic. And the second number refers to drop probability. Okay, so in case of per hop behavior, higher value is better. In case of a drop probability, lower value is better. So which means in case of drop probability, 1, 2, 3 values. So 3 means there is a more chances of packets getting dropped compared to 1 and 2. So which means if I'm receiving any packets with the marking of AF41 and if I'm receiving a packet with AF43, now in terms of priority, both have the same priority, but again, which means both will be forwarded immediately with a high priority. But whereas in case if there is any congestion in the network, now congestion will lead to packets being dropped. We'll talk about congestion management, congestion avoidance mechanism. That's our next section. But again, when there is a congestion means you are receiving excess traffic than what that particular link can send. Then there is a possibility of packets being dropped. Now, when it is dropping, we can say that don't drop high priority traffic. So we can tell that when you want to drop the packets, you just see this drop probability, the last number, and accordingly it can make the decision. So which means this packet is most likely to get dropped compared to this one. So the main advantage of using DSCP values is you get this additional marking options. And in this additional marking options, this last number, you can see this last number will actually decide the drop probability. So this actually decides the drop probability. And accordingly, based on that, the first number defines a priority, just like IP precedence. But in IP precedence, we don't have drop probability option over there. But whereas here, we have an option where we can provide the marking options based on these two values. Like here, you can see this combination values here as well. The next number, the second number will tell the drop probability lesser. This is better. But whereas the first number, higher is better, means 4 is better in terms of per hop behavior. But whereas in terms of drop probability, this value is better. So whenever you are trying to verify the DSCP marking options, you will find these all options. So you'll find this 0 and you'll find this AF values, probably 12 values, and then you have EF, and also you will have CS, that is class selector, which is equivalent to the IP precedence value if you want to have some backward compatibility with IP precedence values. Again, the same thing what I said, DSCP is capability with IP precedence. So because prior to diffserv, we used to have something called precedence field. But whereas nowadays we prefer to use the DSCP. So inside the DSCP, we have this class selector bit, which is going to be considered as equivalent to your IP precedence values.